Hi, my name is Paul Mayer and I'm the collection manager for fossil invertebrates at the Field Museum. Today I'm going to talk to you about how we're improving collection access by having 8 digitization projects over the last 9 years, a little bit of an overview. So over the last 125 years, the Field Museum has amassed or built up a collection of over 2 million fossil invertebrate specimens, divided into about 350,000 specimen lots. But only about 20% of these specimen lots are digitized. The majority of the specimens in the collection have only paper-based records, such as catalogs and specimen labels, storing their information. This makes access to the collection difficult and puts the collection data at risk. So efforts to increase access to our fossil invertebrate collection by digitizing it started in the 1980s with an NSF grant that Scott Litgard submitted and was successfully received to digitize the Mason Creek fossils. Here you can see a few examples of Mason Creek fossils, and here's Eugene Richardson, who collected a lot of Mason Creek fossils from the 1950s on up to the 1980s. And so that collection was successfully digitized using that NSF funding, and resulted in over 35,000 digital records in FileMaker Pro. After that, there was a series of attempts to digitize the entire collection, but really only part of the type, figured, and referred collection were digitized. And it really was just a lack or inability to get funding to do the entire collection, which is quite large. So today my take-home message, which I'll start off with, is that we really do not have the resources to digitize the entire collection at the Field Museum for fossil invertebrates. So in 2012, I came up with a plan to divide the collection into smaller parts or projects and use high school students and undergrad students in the summer as summer jobs and interns to digitize the collection. And after 9 summers and 8 different digitization projects, half of all our digitization records have been created by student interns. And these students are now a critical part of our collection digitization efforts. We can divide the collection digitization project kind of into 3 different groups. There's a historic backlog, and these are just digitizing the specimens that were collected since the Field Museum opened up in 1893 on up to, well, we can say all the way on up to 2012. And that includes the projects that we've been working on in the last 9 years or so. Has been the cephalopod type collection, which is what we started with, as just a way to see how long it took and to get some idea of the numbers, how fast we can do it, and how much effort it is to photograph it, how much memory it takes up. We also did a GDI, a Granger Digital Initiative, where we digitized our Mason Creek type collection. This was a little bit smaller project. And then we had 2 large 3-year IMLS grants, the Silurian Reef IMLS project, which was a 3-year project. And then we're currently working on the Ordovician IMLS project. That should have wrapped up this summer, but with the pandemic, we've asked for an extra year because we just couldn't have interns coming into the museum this summer. So hopefully next summer we'll be able to finish up the last year of the IMLS Ordovician grant. And then we also were able to quickly put in the World Columbian Exposition fossils just from the way they were in the catalog. It was easy to put in just a basic skeleton record for these with the stratigraphic data and the systematics. The other type of digitization project would be new additions. So as we get new collections added to ours, we don't want to add to our backlog. And so recently, in the last 5 years or so, we've had the Thomas V. Testa collection, which was about 8,000 Mason Creek fossils added to our collection, and the James and Sylvia Konechny collection, which introduced another 3,000 or 4,000 Mason Creek fossils. So we've really gotten a lot of nice Mason Creek fossils in the last few years. And using interns through a project at the Field Museum known as the Women in Science project, we funded by the Women's Board at the Field Museum, we've been able to get interns to digitize these collections, and that has been very successful, and this has not added to our backlog at all. And then finally, the last digitization project that we're doing is one on research, and that was our Tully Monster project, where most of the Tully Monsters were already entered into our database, EMU, because of the 1980 Scott Litgard NSF grant. But what we wanted to do was add in photos that NSF grant in the 80s They didn't take photos of the specimens, so those were not added into the database. So we wanted to have photos with a ruler so they could be used to measure various characteristics on it. And we also wanted a way to search the telemonster specimens. We have over 2,000 of them. And we wanted to be able to find morphologic traits, such as did that telemonster have the teeth, the stylets preserved, the head or eyes preserved, the eye bar, the tail. Does it have that stripe pattern, the muscle, myomeres, arcualia, a variety of different morphologic traits. So as we took the photos, we entered into a spreadsheet the different morphologic traits, and then we're able to batch upload that all into EMU. So we can now search through the telemonster specimens and find search for telemonsters that have various of these characteristics or traits. And that helped the researchers really find the specimens they wanted in a short amount of time, so it was quite handy. And so here is our digitization effort since 2012. At the very bottom, you can see the light blue. These are the first project we did, the cephalopod type collection. We did that in the summer of 2012. Then we added in the World Columbian Exposition of fossils, which was a very quick addition that got us up to over 5,000 new specimens. The Granger Mason Creek type specimens, not a huge number, but an important part to get in here, and all photographed. And then our first IMLS grant, the Silurian Reef IMLS grant, you can see this occurred over 3 summers with summer interns entering in data, increasing the numbers each summer by quite a bit sometimes. And that got us close to 25,000. And then here you can see in the turquoise, the Thomas V. Testa collection, and orange is the Konechny collection being added in. And then here's our efforts with the last IMLS grant, our current IMLS grant, the Ordovician, summer number 1 and summer number 2. And then hopefully next year we'll have summer number 3 wrapping that up. And so you can see we've added 40,000 specimens, so we more than doubled what was done in that NSF grant, just using summer interns, which is a really great way of doing this, training interns to learn a database, to handle fossils, to photograph fossils, and so it's been a really nice project. You can also see we've had virtually no images in the database before we switched to EMU, and here you can see these are by the different projects. So cephalopod type, we got in a couple hundred, well, actually about 1,000 photographs. We have not photographed the World Columbian Exposition yet. The Granger Digit Initiative added quite a few photos. We photographed each one of those 4 times, one with normal low-angle lighting and one with cross-polarized lighting, and it was part and counterpart. And then here in pink you can see the Silurian Reef got close to 40,000 specimen images at this point. And then the telemonster, we didn't have many records added with the telemonster project, but we did have a lot of images added, so we got close to 5,000 images added with the telemonster. We have not photographed the Tom Testa, and only a small amount of the Konechny fossils have been photographed in. And then finally we've gotten a lot of Ordovician fossils photographed. We have some volunteers doing this and photographed not only fossil invertebrates, but also the Receptaculites in the paleobotany collection. And so that added quite a bit of photographs, and we're now up to over 80,000 specimen images. Again, done mostly by volunteers and undergrad students. So really increased that in the last nine years. The other thing I wanted to bring up is, we keep track of how long it takes to digitize a specimen, and that includes pulling the specimen from downstairs, bringing it up to our digitization lab, entering the data from the label directly into EMU, photographing the specimen and photographing the label, and then returning it. And this is our first project on the Silurian Reef, divided up into 3 summers. And you can see we worked out some issues here and got the workflow down a lot quicker, I think. And then the third summer you might expect to be even lower, but these were some of the trickier ones and problematic collection, part of the collection, and so it took a little bit longer. This is digitizing the Tom Testa collection. This went really quick because he had everything in an Excel spreadsheet, so it was very quick and easy to put this in. And again, we didn't photograph it, so it's really not comparing the same thing. Here's the Konechny collection. This was all had to be hand done. There was no Excel spreadsheet, and this includes time to photograph them. And then with our Ordovician one, we're finding it's a lot slower because we had a lot of the Silurian Reef localities and taxonomy already in the EMU database, and here we had to add a lot of this as extra, so it's been a lot slower going for us with the Ordovician specimens. And so just to show you our workflow, and this is the old digitization station, it's kind of compact, but we have one place where they photograph the label on a copy stand, then they photograph the fossil at another station, and then finally they enter in the data entry, and we find it's easier just to use the photograph of the label to enter the data right into EMU because it's right next to it, so you don't have to look up and down at the label and at the computer screen. And you can see these are carts. Each cart holds, I think, 7 drawers. And so the interns do 7 drawers at a time, and then go down and get more drawers. And so that way they're kind of responsible, and they just wheel these carts to each different station. And so they stay with one cart and do one completely do those records just to have that finished. This was one from when we were doing the Silurian Reef. Here you can see the new digitization lab. We got copy stands, new computers, which are a little bit faster, makes things easier. One of the key things is the little puffer here to clear out the dust so the photographs look a lot nicer. And we got a little bit more room up here. This is not. This is just before this is the summer before the COVID problem, so we'll have to work out spacing a little bit better than this, but it's a lot easier than in the other room. And so we had 28 interns who helped work on this project. They've all done a great job. They've done photography of the labels, the fossils, and data entry. We also had scientific illustrators like Mary Williams and Monica Jurig and Miranda Zimmerman and Alex, who have been illustrating some of these fossils and what they might look like in real life. So we can add these to our web pages and then create some educational web pages for students, teachers, and they can get a better understanding, especially on the Silurian Reef and the Ordovician. We plan to have quite a bit of information up to help interpret these fossils since these are now available online. So a lot of these specimens, all these records now are available on GBIF, and now just a couple weeks ago we have a database searchable on our geology department website at the Field Museum, so you can now find all these on the Field Museum's website. So thank you.